Hi, it's Rob, and I'd like to welcome you to this Terraform Fundamentals video where we'll start building a foundation and working with Terraform. However, before we start coding, let's get a brief overview of what Terraform is. Terraform is an open source infrastructure as code software tool created by HashiCorp, which enables you to safely and predictably create, change, and improve infrastructure. But what is infrastructure as code? According to AWS, it's the practice of applying the same process of application development to provisioning infrastructure. So instead of going into a console and clicking to deploy resources, you write code which, when executed, provisions the infrastructure according to the specifications you provided. And speaking of AWS, their infrastructure as code tool, as you may know, is CloudFormation. CloudFormation allows developers to write templates in YAML or JSON syntax, which the CloudFormation service uses to provision infrastructure on AWS. So, if AWS has their own tool for infrastructure as code, why would we want to use Terraform? Well, Terraform is cloud agnostic, meaning it can deploy resources on multiple providers, such as AWS, Google Cloud, Microsoft Azure, and more. So if you learn how to deploy resources on one provider in Terraform, you can easily transition to deploying resources on other providers. Now, to get started using Terraform, as mentioned in the playlist intro video, you'll need Terraform installed on your machine, as well as a code editor. And if you're following along with me, you'll also need an AWS account and have the AWS CLI installed and configured. I'll provide links to videos on how to perform these tasks in the description below if you need to get your machine configured. Okay, now let's start writing some code to launch AWS resources in Terraform. First, we'll jump into the Terraform registry, then browse providers, and select the AWS provider. Here, we see we can use the AWS provider to interact with resources supported by AWS. However, before we use it, we must configure the provider with the proper credentials. So if we scroll down, here we see an example usage. So we'll go ahead and copy this, then jump into VS Code and create a new file named main.tf. Then I'll paste the code in. In the code, we see we have three blocks. A Terraform block, which is used to configure some high-level behaviors for Terraform. A provider block, which is used to specify a provider configuration, which in our case is AWS. And a resource block, which declares a resource that we want to provision on our provider. And in this case, the resource is an AWS VPC. Now, jumping back into the AWS provider documentation in the authentication and configuration section, we see that the auth config for the AWS provider can be derived from the sources listed here, which match the order of precedence used by the AWS CLI. And if we scroll down a bit more, we see an example auth configuration where the region, access key, and secret access key are provided. So let's go ahead and copy this and jump back into VS Code and update our provider block. So I'll be working in US East 1, and I need to provide my access key and secret access key. Now, this obviously isn't very secure because ultimately we're going to commit this code to a GitHub repository. So if we jump back into the documentation, we see the warning about hard coding credentials. Now, following the order of precedence that we saw earlier, because we have our CLI configured with the access key and the secret access key, we can actually go ahead and delete these from the provider configuration. And when we execute this code in Terraform, it will pick up the values from our local AWS configuration. Now, jumping back up to the top of the code, we'll take a look inside the Terraform block. As mentioned previously, this block is used to configure behaviors in Terraform, as well as identify providers required for provisioning our infrastructure. For example, here we see we have a required provider for AWS, and the source is pointing to the AWS provider in the HashiCorp registry. The version of the AWS provider is any version in the 4.0 range. So if we jump back over to the provider documentation and click on the user provider button, we'll see that the current version is 4.52.0. Now we could take this version and put that in our code, which would lock the version to this specific 4.52.0, but by using the tilde greater than, this says that any version within the 4.0 range. So this obviously covers 4.52.0. Now, similarly, inside of the Terraform block itself, we can set the required version for Terraform. So if I jump into a terminal and do a Terraform version, I'll see that I'm currently on Terraform 1.3.7. So if I go back to the Terraform block, I can add a required version of Terraform within the 1.3 range. We previously looked at the provider block where we're specifying the provider of AWS and setting the region for me to US East 1. And as we discussed, Terraform will get the access key and secret access key for the IAM user from the AWS config. The last block in our code is a resource block, which specifies we want to create a resource of the AWS VPC type. I'm going to change the name from example to CC VPC for Cumulus Cycles VPC, and this is the name that Terraform will use to reference the AWS VPC that we're creating inside of the Terraform code. And in this case, I'm only specifying one property for the VPC, which is the CIDR block. So now I'll go ahead and save the file, and we can start executing some Terraform commands. The first command I'm going to show you is the Terraform format command. And what it will do is go into all of your Terraform source code and format it properly. So in order to demonstrate that, I'm going to just left align all the code in this file, save it, and jump into a terminal. And in the folder that has our Terraform files, I'll execute a Terraform FMT for Terraform format. And here you can see in the output, it formatted the main.tf file. And if you look at the code in VS Code, you'll see that it's been reformatted. Now, the next command that we're going to execute is Terraform init. And this will read the configuration files to identify the providers that are required for our infrastructure and download the appropriate plugins. So here I'll execute Terraform init, which as we can see is initializing the provider plugins for HashiCorp AWS, matching the latest version in the 4.n range. And looking over in VS Code, we'll see that there's a new .terraform folder, which inside has a Terraform provider for AWS version 4.52.0. The next command we'll execute is Terraform validate, which will run through our Terraform source code files and ensure that we don't have any syntax errors. Now, this command can only be run after executing Terraform init. And here we can see our code passes the validation. Now we'll execute a Terraform plan. And what Terraform plan does is to create an execution plan which will show a preview of the changes that will be made to our infrastructure. So it compares what we call the desired state of our infrastructure, which is defined in our source code files, to the actual state of the infrastructure, in our case on AWS. And because we haven't applied our Terraform configuration yet to actually build our infrastructure, the desired state of having one AWS VPC with the specified CIDR block doesn't yet exist in the actual state on AWS. So when we run Terraform plan against our Terraform configuration, here we see that a resource of AWS VPC.ccVPC, so the name that we're giving the VPC inside of Terraform, will be created. The plus sign indicates that this resource will be created as actual infrastructure on AWS. In the CIDR block property, we see the CIDR block that we specified inside of our configuration, but we also see a number of properties which have a value of known after apply. And the Terraform apply command is what we execute to actually take the desired state in our Terraform code and build the infrastructure on AWS. So after we execute Terraform apply, these values will be known because the infrastructure will have been provisioned. So let's go ahead and clear this out and run a Terraform apply. Now again, we see the execution plan, and it's asking us to enter yes to actually execute the plan. So we'll go ahead and do that. And it says that the AWS VPC has been created with 1 resource added, 0 changed, and 0 destroyed. So if we jump over into the AWS console, here we see we have 2 VPCs in US East. If we click in, here we see the default VPC, and if we select the VPC of 10.0.0.16, this is the VPC that we declared inside of our Terraform block, which was created when we executed Terraform apply. Now, back inside our code, inside of the VPC resource block, I'm going to go ahead and add a tags property, and I'll set the name tag of the VPC to ccVPC and the project to ccTFDemo. Now I'll go ahead and save this file and jump back into the terminal, execute a Terraform validate, which was successful, then a Terraform plan, which shows us that the AWS VPC named ccVPC will be updated in place. The yellow tilde indicates that this resource will be changed, and the plus indicates that this will be adding the tags of name and project. And here in the plan, we see there are 0 resources to be added since we're only modifying the existing resource to add tags to it. That resource is the one that will be changed, and there are 0 to destroy. So here we'll execute a Terraform apply, and I'll pass it the auto approve flag so that we don't have to type yes for the plan to be applied. And we see the apply is complete, 0 resources were added, 1 was changed, and none destroyed. So if we jump back over to the AWS VPC console and refresh, now we see our VPC with the CIDR 10.0.0.016 has a tag of name equal to ccVPC. Finally, let's jump back over to the terminal, and we'll execute a Terraform destroy, which will destroy the infrastructure that we just created on AWS. So here, Terraform destroy gives us an execution plan indicating that the AWS VPC will be destroyed. And before I jump down and type yes to apply the execution plan, if we look inside the resource block, we'll see that the values for the VPC, which were originally set to known after apply before we applied our plan, now have actual values in there. But since we're going to destroy this, I'll hop down here, enter yes, and execute the destroy plan. Now the destroy is complete. 1 resource has been destroyed. And if we jump back over to the VPC console and refresh, we now see we only have the one default VPC. Now, let's jump back into our code and take a look at what we've written. Although this file is pretty small right now, it's not really following best practices of application development because it's a single file with multiple blocks, and it has several hard-coded property values. So what we're going to do now is make this code a bit more reusable by breaking the blocks out into separate files and passing variables into the block's properties. So we'll start by creating a new file named providers.tf. Then we'll jump back into the main TF, cut the provider block out, and paste it into the providers TF file. Then we'll create another file named vpc.tf, jump into the main file, and cut the VPC resource block out, and paste it into vpc.tf file. Now if we jump back to main, we see that here we're only specifying the Terraform block with the required version and the required providers. Then inside of the providers TF file, we're specifying the provider block, and if we had other providers, we could add them here, making sure to include them in the required provider section of the Terraform block. And finally, in the VPC, we see we have the resource that creates the VPC. So this is getting a little better into following best practices for application development, because now we have a separation of concerns where the main TF file is only handling the Terraform configuration and specifying the required providers. The providers TF file just specifies the providers, and the VPC just has the resource block for the VPC. However, we still have several hard-coded property values. So in order to address that, what we'll do is we'll create a file named variables.tf, and inside we'll declare variable blocks for the variables that we want to set dynamic values for. Now in main.tf, we'll leave this as specified, and the same inside of the providers. However, in the VPC, what we'll want to do is pass the value for the CIDR block and the tags in as variables. So in the variables.tf file, we'll start by specifying that we want to declare a variable, and we'll give it a name of VPC CIDR. We'll add a description, which will be the CIDR for the VPC, and then we'll specify the variable type. Now, in Terraform, the variable types we can define are string, number, boolean, list, set, map, object, or tuple. And variables are typically divided into inputs and outputs. Input variables are used to pass data into your templates to set property values when provisioning your infrastructure. And output variables are used to display data on your infrastructure after deployment. Starting with input variables, they're defined using the keyword variable followed by the name and then the variable properties. Now, let's take a look at some common input variable types, starting with a string. And here we see we're declaring a variable. Its name is region. Its type is a string, and it has a default value of US East 1. And its usage would be to set the region equal to var.variable name. So after this code were to execute, the region would be equal to US East 1. Here's another example where we declare a variable. Its name is bucket name. The description is remote S3 bucket name, and its type is a string. Here we haven't given it a default value, but we could add a validation block to ensure that when this variable is assigned a value, it adheres to the S3 naming conventions. So we'll do that by setting the validation condition equal to passing a regex expression for the syntax of the S3 bucket names and the bucket name variable into the can function, which will return true or false. If this returns true, then we have a bucket name. Else, we'll set the error message equal to the bucket name must not be an empty string and must follow S3 naming rules. The next variable type we'll look at is the list. Here we're declaring a variable. Its name is availability zones. Its type is a list of strings. The default values will be the list, which is contained in square brackets, of strings, with the first value being USD East 1A, then 1B and 1C. Now, the usage is we'll set the value of the first AZ property equal to going to the variable named availability zones and getting the value at the 0th index. So that would be going to the variable named availability zones, and the 0th index of its values is USD East 1A. The second AZ would be in the position index 1, and USD East 1C would be in position index 2. Next, we'll look at a map where we declare a variable named region availability zones. Its type is map, and it has a default value with key value pairs. So the first key is US East 1, and its value is USD East 1A. The second key is USD East 2, with its value being USD East 2A. And the usage would be to set the value of the primary prod region equal to going to the variable with the name region availability zones, passing in the key of US East 1. So we'd go to the variable region availability zones and look for the key of US East 1 and return the value of US East 1A. To set the primary DR region, again we go to the variable named region availability zones, this time looking for the value of key US West 1, which would return US West 1A. The final input variable type we'll look at is the Boolean, where here we have a variable named multi-region with a default value of false. Now, we haven't set a variable type here, which actually isn't required in variables because Terraform is smart enough to determine the type of variable based on its value. So in this case, since the value can either be true or false, we'll just specify the default value. And then the usage is to set the value of the multi-region deployment equal to going to the variable named multi-region and getting its value. Now, the final thing I want to mention on input variables is, in addition to declaring them inside of a file, which Terraform will use when it's provisioning infrastructure, you can also pass variables as arguments on the command line. Finally, moving down to output variables, you'll recall that in our code, we defined a resource of AWS VPC type and gave it a name of CC VPC. Then inside, we defined the CIDR blocks and tags. Now, if we wanted to print the value of the ID for the VPC after it's provisioned, we'll use an output block, give it a name, and set its value equal to going to the resource type, which is AWS VPC, then specifying the resource name, which is CC VPC, and then the property that we want to display. And after the infrastructure is provisioned, the VPC ID will be printed out with the value from the provisioned resource. Now, with an understanding of Terraform variables, we can turn our attention back to our code and add the type for our VPC CIDR. And in our case, our type is going to be a string. Now, in the variable declaration, we can also specify a default value. In here, we'll give our VPC CIDR a default value of 10.0.0.0/16, which is what we had originally defined in our VPC. Now, instead of hard-coding the value in the VPC, we can reference the value inside of the VPC CIDR by specifying var, dot, and then the variable name. And since we gave this a default value, the value of the CIDR block will be set to 10.0.0.0/16. Now, for the tags, in the variables TF file, we'll create another variable named VPC tags, give it a description of tags for VPC, and its type will be a map. And we'll specify the default values of name equal to CCVPC and project equal to CCTF demo. Then in the VPCTF file, we'll set the tag's property value equal to var.vpc tags. Now let's go ahead and save these files, jump back into the terminal, do a Terraform format, and a Terraform validate. Now with our validation successful, we'll run a Terraform plan. And we see that one resource of AWS VPC.ccVPC will be created. Its CIDR block is set to 10.0.0.0/16, and its tags have the values of name of CCVPC and the project set to CCTF demo. Now this is looking better because we're passing the values for the properties via variables which are declared in the variables TF file instead of hard coding them into the resource block. However, inside of the variables, we're always specifying default values for the CIDR range and the tags. Now, what if we wanted to create the VPC, but we didn't want to default it to 10.0.0.0/16? Or we decided we wanted to change the name of one of the tags. Well, here we'd have to go into the variables file and change the default value. So if it's the case that the default value for the properties which are being set from the variables could change, then we don't want to set the default values inside of the variables TF file. And for that, what we'll do is we'll create a new file named terraform.tfvars. And this is a specific naming convention. And in this file, when we run Terraform plan and Terraform apply, Terraform will look inside of the variables to see the variables that have been declared. And then it'll look inside of the terraform.tfvars file to see if there are any values set for those variables. So here, what we're going to do inside of the Terraform TFVars file is set the value for the VPC CIDR equal to 10.0.0.0/16, or whatever value that we want to declare when we provision this infrastructure, and set the VPC tags for the name and project. And then in the variables TF file, we'll delete the default values and save the files, go back to the terminal, run a Terraform format, a Terraform validate, and a Terraform plan. And again, we see our resource will be created. It has the appropriate value for the CIDR block and the appropriate values for the tags. Now we'll execute Terraform apply, passing auto approve. And we see the apply is complete with one resource added. So we'll jump back into the AWS VPC console, refresh, and now we see our VPC is back again. So here I'm going to quickly run a Terraform destroy. And just refresh the VPC console and confirm that our VPC has been destroyed, and we see that was successful. Now, before we wrap up this video, there's one more thing I'd like to demonstrate, and that's using output variables. So I'll create a new file named outputs.tf. Then in the file, I'll declare an output block, give the output a name of VPC ID, and set the value equal to going into our VPC, grabbing the resource type, then specifying the name of the VPC and the property. Now I'll save the file, Go back into the terminal, run the Terraform format, a Terraform validate, and a Terraform apply. Here we see our VPC will be created as expected, and here we see that the output for VPC ID will be known after the apply. So I'll go ahead and enter yes to apply the plan. And after the apply is complete, we see we have our one resource and the value of the VPC ID is displayed in the outputs. And to clean up, I'll do a Terraform destroy, passing it auto approve. And our resource has been destroyed. So that concludes this video on Terraform Fundamentals, where we looked at the Terraform block, providers, variables, and executed Terraform commands such as format, init, validate, plan, apply, and destroy. In the next video, we'll look at creating modules in Terraform. So if you'd like to be notified when I add that video to the playlist, please consider subscribing to the channel. And if you found this video informative, feel free to give it a thumbs up. Thanks for watching, and I hope to see you in future videos in this Infrastructure as Code on AWS with Terraform playlist.